Page 28 as we are taking a look at this. So last week on Friday we did the multiplication division. Now we are looking at addition, subtraction in scientific notation. And the key thing that you need to know, when you're adding or subtracting numbers in scientific notation, both numbers must first have the same exponent of 10. They must first have the same exponent of 10. So these two can be added because they're both 10 to the thirds. And what's nice is that then you're just going to add or subtract the number that's in front. So if we were adding 280 times 10 to the third and 1.5 times 10 to the third, we'd add 280 plus the 1.5 and get 281.5, and we keep it times 10 to the third. That doesn't change. But when we write our final answer in scientific notation, the first number must be between 1 and 10. So we're going to move the decimal back in between the 2 and the 8. So we'll get 2.815. How many places? Before we had to move it 3. Now we have to move it 4, 5 places. So this would be our final answer. So operations with scientific notation. This is kind of a mnemonic that we sometimes use. It's called LARS. What does LARS mean? LARS stands for left add, right subtract. So when we do this, and as we go through a few of the problems today, and then you're going to have a lot of time to work on the two worksheets. So it says use LARS to help you move the decimal to the right in the right direction. For example, if we are adding 4 times 10 to the 6th plus 3 times 10 to the 5th, since our decimal has to be moved to the right, we are going to add. That means since we moved it to the right, when you move it to the right, you are subtracting the power left add. So in this case, we moved it back to the left. That means instead of 5, we now add 1 and we get 6. We are adding these two together, 4.3 times 10 to the 6th. So in your homework, or on your notes, if you would please look at these first two. Are the first two with 10 to the same power? 3.6 times 10 to the 5 plus 4.7 times 10 to the 5, exactly the same. So what we're going to do is we're going to line them up, and we're going to put right below this 4.7 times 10 to the 5th. This vertical addition seems to be easier for most of you when you're doing this, so this stays the same. So the power stays the same. You are not going to add make it 10 to the 10th. That is going to stay as 10 to the 5th. We keep the times, and now you are adding 3.6 plus 4.7. So when we start to do that addition, we are going to have 7 plus 3 gives us 13. We carry the 1, 4 plus 3, 7.3 times 10 to the 5th. This is in scientific notation, so we are done with the problem at this point. Yes? 8.3. Not 7. Thank you. 8.3. 4 plus 3 plus the 1. So let's go to the next one over here. We take a look at 3.45 times 10 to the third. We have another addition problem. So making sure you identify if you are doing addition or subtraction. These first two were addition, right? The second two are subtraction. So when we take a look at this problem, if we are adding, we do not have the same power. The other thing you always want to do when you are adding and subtracting is go big, go big, go big. So if we're going to go big, we want the larger power. So we're going to keep 4.65 times 10 to the 4th. We need the first one to also be 10 to the 4th. This was telling us to move it over 3 places. That's what this scientific notation is. If I was going to write this number out in standard form, it would have been not what some of you made the mistake on the quiz, not adding 3 zeros behind it, but moving the decimal 3 places. So this is what it would look like. If we're going to have it times 10 to the 4th, that means if we are moving it to the left, we need to add 1. So we're going to put 0.345 times 10 to the 4th. We are adding these. We moved our decimal to the left to get to the power. We've got to add to the exponent. This stays as 10 to the 4th. We are now adding these two together. If you need to add another place value as you are adding those, add that last place value. So if we are looking, this is really going to be a 0 here. So 0 plus 5 gives us 5. 4 plus 5 gives us 9. 6 plus 3 gives us 9. 4.995 times 10 to the 4th. If I was looking at that answer in standard form, okay, so this is our scientific notation. On the quiz, you had to write it in standard form. Standard form means I would be moving this over 4 places. So what would that number look like? 49950. So the mistake some of you made on that quiz, and just for a refresher, some of you will be taking that quiz. If you are switching from scientific notation to standard form, scientific notation, the first number must be between 1 and 10 times 10 to the 4th. So we're going to take a look at the subtraction ones on the bottom, and then we're going to do a couple examples and get you started on your homework. So the subtraction ones. As we are doing subtraction, here we have 15th, here we have 14th. We want to keep the same power. So we're going to put 3.57 times 10 to the 15th. If we want to have the second one being 10 to the 15th, that means I'm going to add to the 14th. That means I have to move my decimal to the left is add. That's going to give me 10 to the 15th. This is now going to be, when I put that decimal point, 0.465. What I had some of you do on the quiz also is you just drop some of these digits, so you just got to be really careful and keep those in place. And this is subtraction, so make sure you do the subtraction. Again, we're going to keep the 10 to the 15th. That doesn't change. So now this time you are subtracting. If you need to use your calculator, I got 3.11. Okay. So I agree with that here. We are going to have 10 minus 5 gives us 5. Did you get that? 6 minus 6 is 0. Did you get 1, 1 or 1, 0? Okay. So just watch that, because you are changing this to a 6, and 6 minus 6. I saw a couple other people that had 3.115 also when you're taking a look at that. So this is scientific notation. It's perfect in scientific notation. This first number is between 1 and 10 times 10 to a power. If I was going to ask you to write this out in standard form, how many zeros would I need to have behind the 5? How many zeros am I looking at behind that 5, Caitlin? How many? 12 or 15? 12 zeros, right? So when you look at this, this is a huge number. We've already moved it 3 places for part of that 15. It doesn't mean put 15 zeros. It means move your decimal 15 places is what we are looking at for that scientific notation. All right, so let's look at this last one. This one's a little tricky. You might have some like this in your homework. On the problems on page, when we are working on page 53 and 54. So the first thing, we want to go big, right? Which is bigger, -2 or -1? -1, right? If we think of a number line, here's 0, here's -1, here's -2. -1 is larger than -2. So we want to keep it with -1. That means if we are going to add 1 to this, this is going to become, if we are going to add to get -1, it's going to be 0.945. So 0.945 times 10 to the -1. This one stays the same. Can you take 0.945 minus the 2.1 if we are looking at that? And my hint is for you, is since 2.1 is larger, we're going to put that first, a -2.1 times 10 to the -1. And we are going to add, because in front of this it's positive, 0.945. If you don't have a calculator, grab a calculator. And we are going to subtract these, because you will need it when we do our assignment. So 0.155. Everyone agree when you put that in your calculator? Okay. So if I was looking at this number, and this is my answer in scientific notation, and you're answering a story problem, because we're going to look at one of the story problems next, but when you take a look at this, what does this number look like in standard form? What would it be in standard form? Which way should I move my decimal point? To the left or to the right? So So this negative, is it a number bigger than 1 or less? The negative exponent, what does negative tell us? Negative is going to go smaller, right? So here, when it was positive, we moved it 15 places to the right. Because we are looking at a negative exponent, negative tells us to move the decimal to the left. So this number would be moving 1 place to the left, negative 0.1155. That's what it would look like in standard notation. So that's like, if we were saying it, that's like 11 hundredths, right? If we were looking at that, just the first 2 place values, okay? So the other one we want to look at is the scientific notation, the story prep. So we already did page 29, so please turn over to page 30 in your notes, and that bottom half of page 30. So, on page 30, which operation do I need to perform to solve it, okay? So, one of the questions we're going to ask you in your homework is, what is the operation, and then you'll have to perform it. And I'm going to give you an extra worksheet with some extra practice. So the area of the Pacific Ocean is 6 times 10 to the 7th square miles. The area of the Atlantic Ocean is 2.96 times 10 to the 7th. Which one's larger? Pacific or Atlantic? If we're comparing them. Because both have 10 to the 7th, so Pacific is larger because 6 is greater than 2.96, right? And it says about how many times greater. If you're ever trying to find times greater, how many times greater is Pacific than Atlantic? This is really trying to tell you to do division. How many times greater? You're going to take the Pacific Ocean and you're going to divide it by the Atlantic Ocean. So the Pacific Ocean, we would take 6 times 10 to the 7th divided by 2.96 times 10 to the 7th. Our exponent rules say 10 to the 7th divided by 10 to the 7th. That is simply going to be 10 to the 0. We're going to subtract. 7 minus 7 gives us 10 to the 0. So we are dividing is what we want to put. And if we solve this problem, 6 divided by 2.96 on your calculator gives us what? Please do that. 6 divided by 2.96. And we're usually going to go 3 decimal places. So we'd say 2 or 2 numbers behind, 2 point, what did we get? Did we put that in? 0.27, so if we go 3 places, okay? So as we are taking a look at that, how many times bigger is the Pacific than the Atlantic? 2.027 times 10 to the 2nd. How many times bigger would you just tell someone? What's anything times 10 to the 0? 10 to the 0 equals 1. So this is like just saying 2 times in this kind of greater area. Okay? You're going to have some story problems like this on your test, right? You're going to have actually 4 different story problems next week when we take the test. You're going to be asked what's the operation and then to perform. Okay, so now we want to look at this next one. It says the sun burns at about 4.4 times 10 to the 6 tons of hydrogen per second. So this is our hydrogen per second. It says how much hydrogen did the sun burn in 1 year? Well, first off, let's think about how in science you would have written this as 4.4 times 10 to the 6. This is tons of hydrogen, okay? Please write this in your paper. Per, this is the per right here. This line means per, our division. Per, if we think of our unit rates, second. And it says 1 light year is 3.16 times 10 to the 7th. And we're figuring out how much burns in 1 light year. What operation are you thinking we should be? So I agree, we are going to multiply, but why multiply? Because we want to go how many years, and we have 1 year, so we're going to think of it this way. We have 1 year, right? Because we're trying to find hydrogen per year. So we're trying to find out how much hydrogen per 1 year, okay? That means we have to put this 3.16 times 10 to the 7th. So when we start multiplying on your calculator, doing our multiplication from last week, 4.4 times 3.16. That's going to be our first part of our answer. Times 10 to the 6th times 10 to the 7th. So when I'm looking at this problem, Sam, 10 to the 6th times 10 to the 7th, I have the same base. What am I going to get? So I'm going to keep the 10, right? And I'm going to have 10 to what power? When I multiply, what do I do with my exponents? Add. So 6 plus 7 gives us 13. When we do the multiplication, Patrick, what did you get when you multiply those?
13.904.
904, so we go back 3 places. This is not in scientific notation. Jordan, you ready to help us change it? It was 13. We want our final answer, so we're going to say here that we were multiplying. And our final answer would be 1 point. If I go 39, to what power, Jordan? I move it here. To the 14. It was 13. This is telling us to move it 13 places. We have to move it 1 more, so times 10 to the 14. Okay? So in your homework tonight, you're going to have some story problems that you are looking at. If you would please turn back to page 53 in your homework. I've already ranked these, the top ones. This is our problem, and this is why I did not want you last week to do 2 through 4. It says, what's the difference from the largest mass to the smallest? So, the smallest we had is Pluto. What did you guys have for your largest one at 11? What was number 11? The sun. Okay? So, it says, what's the difference? This is what I want you to do. We have to keep the same power, right? So we're going to write this as, do we want it to be 30 or 22? Key thing, go what? Go big. So, 2, yes, or go home. So you're going to go big. We're going to go 2.03. I want you to write this way back here, times 10 to the 30th. Why do I want to leave it so far back? Because this one, and I saw some of you with bazillions of zeros on your paper, erase. This one, we need to now write the Pluto as 10 to the 30th power. If this is going to be 10 to the 30th power, how many places do I need to move my decimal to the left to get to 30? 22 plus what gives me 30? 8. I need to move this decimal 8 places, which means if I'm moving it 8 places, right, I'm going to have 1, 2, 3, 4, 5, 6, 7, 109. So you should have these two written down on your paper, and you are going to add them.